Welcome to Developing Graphics Frameworks with Python and OpenGL, Part 29, Rendering a Scene. Well, the graphics framework is really coming together. In the last video, we finished working with some basic material classes. The next class we need to create is renderer, and once we have that one, we're ready to render a scene. So in the second half of this video, we're also going to create our first scene with a framework. It gives us a really nice high-level approach to creating 3D scenes. All right. So in the rendering process, here's some of the tasks which we've had to do previously when creating an application. Once we started working with depth, the z-coordinate and projection matrices, we needed to enable depth testing, and we also like to set the clear color. That's the color used kind of for the background. And then in the renderer, most of the action is going to happen in a render function. It's going to take two objects as input. The scene, which contains all the different meshes and things, and a camera from whose viewpoint the scene will be rendered. So we need to store those two objects. We'll need to clear the color and depth buffers, update the view matrix of the camera. In a previous video, we talked about that's the inverse of the camera's model matrix. And then generate a list of all the mesh objects in this scene. Now, it's a little bit tricky because the scene stores all the different objects in a tree structure for good reasons we talked about in a previous video. But for simplicity in iterating over this set, it'll be helpful to convert it to a list. And we can do that with a function we wrote previously called getDescendantList. Now, in the scene, there could be lots of different things. For example, some nodes just might be used to group other nodes. Those are called instances of the group class. The camera is also an object in the scene. But when we're actually rendering things, it's really only the mesh objects which correspond to visible things. So we'll need to filter through that list we obtained using some built-in Python functions, filter and isInstance. So we'll need to get that list of mesh objects, and then once we have them, again, we have to perform all those tasks that we've done in every application loading up to this one. We have to specify the shader program being used to render an object. We need to bind a vertex array object. That ensures we're using the correct vertex buffers. Whatever values are currently in the model, view, and projection matrices, we need to copy those into uniforms. Right? You might recall that the values of those matrices are stored in the mesh in the camera. The mesh has a model matrix. The camera stores view and projection matrices, but those values need to get into the uniforms of the material. So at this step, we'll also perform that task. Once we've finished updating that, the values from the uniforms need to be uploaded to the GPU. Also, remember that materials store render settings, so we need to apply those render settings, and that's specified by the update render settings function. And then, once all that's done, the actual rendering happens when you call the GL draw arrays function. That's going to specify the draw mode, which we stored in the settings dictionary. It also specifies the number of vertices being rendered, and that's stored in the geometry. It contains all the vertex data. All right. So, a fair amount to do, but remember, once we write it in the renderer class, we won't have to worry about these. All right, renderer is really one of our core classes, so we're going to go ahead and right-click on the core directory and create a new file, immediately save it with the name renderer.py. Okay, for the renderer, what are we going to need? First, we're going to need some OpenGL constants and functions. So from OpenGL.gl, import everything. And we're also extracting a list of mesh objects, so we should import that class too. From core.mesh, import mesh. And let's make our class renderer. Right, so define the init function. For a clear color, we'll give it a default value. We'll say maybe use black by default. But in theory, you could give any RGB values here and set a different clear color if you wish. Really, the only two initialization tasks we mentioned, we want to enable depth testing. So we do that with a function GL enable, the constant GL depth test. And then we'll specify the clear color with GL clear color. And we need to, well, extract the components from this argument. So clear color 0, clear color 1, clear color 2. That's it for initialization. Let's go ahead and set up the render function. This is far more interesting. So we need a scene, and we need to know the camera that we're going to use. And you might think, well, do you really have to specify the camera? Can't you just go through the scene and pull out the camera object? That depends if you're going to have only one camera or potentially more than one camera. In future demos, we might have more than one, so we'll specify it here. All right, first, let's clear the buffers, the color buffer and the depth buffer. Do that with a function GL clear, GL color buffer bit, combined with the bitwise OR, GL depth buffer bit. All right. Next, we're going to update the camera view. See, so this is going to be from that camera. Let's go ahead and update the view matrix. And that calculates the inverse of its model matrix. That's a really intensely computational task. So it's far more efficient to do it once at this stage. Right, next, from the scene, we're going to extract a list of mesh objects from the scene. Right, so let's say maybe descendant list. From the scene, it's an object 3D, and we did write this nice convenient function, get descendant list. Again, that contains everything, including the root, which is a scene. It includes groups, it includes cameras. So we need to filter it. To do that, we're going to create a function, and we're going to use lambda notation for that. It's just a simple way to define a function in just one line. So this is a function of x, and it returns the value of the expression is instance x mesh. This is actually why we need to load the mesh class as well, so it knows what a mesh object looks like. So this defines a function called mesh filter, and then to create the list of mesh objects, we might say I want to apply mesh filter to the descendant list, but we also want to convert that into a list. So we're also going to wrap this in a list function. All right, and this will give us a list of objects which pass this test, which identify if something's a mesh. All right, we've got the list of mesh objects. So for each mesh in the mesh list, first, you might recall we have a visible variable, right? So if the mesh is not visible, continue to next object in the list. Right? Don't spend time trying to render something you can't see. So if it's not the case that the mesh is visible, continue. Right? That skips the rest of the code in the for loop and would return to the next iteration. Okay, next we're going to go ahead and set the program. GLU's program, and that information is stored in the material. So mesh material, we call that program ref. We need to make sure we're using the correct vertex data. So we're going to bind a vertex array object, GL bind vertex array. And that's actually stored at the mesh level. That's mesh.vaoref. Next, we're going to go ahead and update uniform matrices. So this is mesh.material.uniforms. And one of the uniforms is model matrix. Its data is from this mesh. Figure out its position in the world. All right, so figure out what that matrix is going to be and put a copy of that here. Similarly, see, it's so similar. I'll copy some of this. For the view matrix, its data comes from the camera's view matrix. And finally, the projection matrix, its data comes from, again, the camera. Can I put that on one line? I bet I can. Camera.projection matrix. All right. And I don't know why I made view matrix a function. That's not actually a function. It's a field in there. All right. So we've updated those three uniforms. Now we also need to upload all data from all uniforms to the GPU. And so next step will be to update the uniforms stored in the material. Scroll down a bit, enlarge that again. So for the variable name, I'm iterating over a dictionary again, so I'm using that same syntax as before. And so for each variable name and corresponding uniform object in the mesh.material.uniforms.items. I'm sorry, I need to zoom out again for you to see all of this. All right, for each one of those uniform objects, I want to go ahead and upload the data. No, I didn't actually need to iterate over items. I need to iterate over just the uniform objects. All right, let's update render settings as well. Update render settings. That's conveniently handled by mesh.material.update render settings. And the last part, everything's been uploaded. It's time to call GL draw arrays. It's been a while, but you might recall we need a few pieces of information to do that. First, we need to know what the draw style is. Is it GL points? Is it GL lines? And so forth. And so this is our first parameter. Right, retrieve the draw style from material settings. Next, we use 0. And finally, mesh.geometry.vertex count. And maybe I'll put that on the next line to make it slightly more readable. All right, that is the renderer class. I think that looks pretty good. We can go ahead and save that. Deep breath. We are ready to create an application. Finally, we can test, see if there's any typos, hopefully no typos in any of our previous work. So we're going to create a test class. So I think this is video 29. Wow, it's been since video 22 is the last time we created a test class. This is far overdue. Okay, so in the root folder, I'm going to go ahead and right click and make a new file called test29.py. Oh, it's not code. Let me save that under the name test29.py. Okay, let's go ahead and take a look at a slide one last time. So when we create an application, typically we're going to need to use at least 7 classes, and 7 is sufficient, but depending on how many different shapes and styles, you might have more. As we know, all classes extend the base class. We're going to need a scene to add our objects to, and a camera to view it from. The scene will contain many mesh objects, each of which uses a geometry and a material. And we'll also need the renderer class to actually show us what the application looks like. Right, so we'll need to put in these 7 classes. But as you're going to see, the code for this application is at a significantly higher level than the applications that we've written before. So back to Sublime Text. Let's go ahead and start some imports from core.base. Let's import base. And always be careful of capitalization. From core.renderer, let's import renderer. From core.scene, let's import scene. From core.camera, let's import camera. From core.mesh, let's import mesh. Now I imagine in a future video we're going to want to create some kind of a template file to save us a few minutes of typing in these standard lines of code. Now we get to pick which geometric objects we render. So we're going to go ahead and render the box geometry. Really, we have box and rectangle to choose from at this point. So let's go with a fancier one. Okay, so from geometry.boxgeometry, import that. And then from material.surfaceBasicMaterial, we're going to import surface basic material. Okay. So now let's go ahead and render a scene. Okay. So I always like to call my classes test. They always extend base. And you might remember there's 2 functions we have to implement whenever we extend the base class. There's an initialize function. I always like to print a message. Initializing program. And now let's set up all our different objects. And a lot of these will have to be class level variables because we're going to need them in the update function as well. So I need a renderer. We need a scene. We need a camera. Let's see, we're going to set up a mesh, but before we set up the mesh, I'm going to create a geometry object, a box geometry. And for the material, we're going to use a surface basic material. And I'd like to use vertex colors. By default, vertex colors are turned off, so I want to override that uniform, and this is where the dictionary becomes useful. So the property, in this case the uniform, called useVertexColors, I'm going to set that to 1. And so that's my new property. Okay, once we've got that, a few things I want to do. So the mesh, self.mesh, I'm going to create a new mesh Remember, to initialize a mesh, you need both a geometry and a material. And then we need to add the mesh to the scene. You can create something, but if you don't put it in your scene, you're not going to see it. Now, the other thing we need to worry about is the position of these objects. By default, everything's at 0, 0, 0. Right? So the camera's going to be at 0, 0, 0. So is the box. So the camera's going to be inside the box. What I'd like to do is kind of pull the camera out towards the viewer, which means giving it a position on the positive z-axis. So thinking about the composition of my scene, let's say we want to pull camera towards the viewer. And so I can say, for example, self.camera. And remember, in the 3D object class, we wrote a lot of functions. Really, all of this work is paying off now. I'm going to give it this position in the scene. Okay, that sets the scene. Do we want to do anything in the update function? Well, there's always something we have to do in update. Right? We always have to render the scene. So and that's taken care of by the renderer object. So render self.scene and self.camera. And then, once we're done with that, we're going to go ahead and remember to instantiate the class. Instantiate and run the class. So create a test and call run. Right, the moment of truth, are we going to see some part of a cube? Let's get in Tools, Build, and see what we see. All right, hello from the Pygame community. Hello. This is our first time running it, so it's probably compiling all sorts of stuff in the background. Oh, let's see. Import. No module named material. Oh, I called that directory materials instead of material. Spelling is important. Okay. Since I used singular for geometry, I'm going to want to use singular for material as well. So I'm going to right-click and rename that to just material. I think that'll be okay with our other files, right? So I always used material dot. Okay, that's fixable. Let's go ahead and try building that again. All right, little Pygame. All right, I see the Pygame window, but I don't see anything there. What's happening next? So we set up the renderer. When setting up the GL clear color, GL clear color actually takes 4 values, RGBA. So in the renderer, I need to add 1 more bit of code. Right, so GL clear color, right, that didn't work out. Let's add a 1.0 so we get an opaque clear color. All right, save that change to renderer. All right, bug number 2 is stopped. Let's try this one more time. 3rd time's the charm, unless it's the 4th. Let's see, a renderer object is not callable. Oh, from renderer, I need to call the render function. I'm so excited. Let's try that again. Save and build. Right, renderer, call the render function. Now can I see a cube? It's a cube. I know what you're thinking. No, that's a square. Well, it's a cube. We're looking straight on in that z direction. We need to spin that cube. And so let's do that. Let's go to the update function. Let's do self.mesh.rotate. Let's rotate it around the x and y axes. Doesn't really matter how much we rotate it by. Remember, this is in radians, and this is per frame, so this happens 60 times a second. So make sure these numbers aren't too big. So self.mesh, let's also do maybe a rotate Y. I don't know, 514. Cool. Right, let's try again. Let's make a spinning cube. Let's go ahead and build that with some rotation around the X and Y axes. Oh, what don't you like? Object matrix has no attribute make rotate X. Let's see, this is an error from way back. So matrix has no make rotate X. Oh, because it's called make rotation X. Well, this is good. We're figuring out all these problems now. Let's go fix this. So to make a matrix, the name of the function is make rotation X. I think when we set up the object3D class, we called it make rotate X. So within the core directory, let's head over to object3d.py and let's look for rotate X. Yep, there we go. Make rotate X should be make rotation X. Right? In order to rotate the verb, you make a rotation matrix, adjective. So make rotation X, make rotation Y, and make rotation Z. So again, if you've been following along, in the object3D class, we need to change the names of those functions to make rotation. All right, that's saved. Let's try this again. I really want to make that thing rotate. And there we go. Have ourselves a rotating cube. All right, let's keep this over here to one side. And let's go through the code for a moment, because this is just really nice short code. Now let's appreciate how brief this is. We have a lot of import statements, this is true. But then we say we're extending the base class. A lot of this is going to be boilerplate. It's going to be all templated later on. So creating a renderer, a scene, and a camera. We specify the objects and some of the different settings. And then we just add things to our scene. That's all there is to it. And you can do fun little things with it. But this code is, again, very high level. You can think about things like which objects you want at which positions, and all the classes we put together will really accelerate the development and creation of 3D scenes. So that's very fun. If you want, you can experiment with adding more objects to this as well. Right? I gave self, I called the mesh self.mesh, so I could refer to it later on in the update function. If you don't want to add this, or if you don't want to alter it in the update function, you can create additional meshes pretty easily. Like for example, I might say want to create, let's call this one, let's call it backdrop. And this is going to be a mesh, and I need to give it a geometry and a material. Let's leave that blank for now. Add a backdrop. Right, so let's create a back geometry. That's going to be, again, we're using a box geometry. But here I'll set a width and a height. So maybe the width is 2, the height is 2, and the depth, it can actually be pretty thin. Make that 0.1. Even 0.01. And then let's create just a solid colored box in this case. Right, so this can be a material, let's call it back material. That'll be, again, a surface basic material. In this case, I'd like to set the base color. So again, I do this with the geometry. So the base color, let's make this maybe a yellow color. Again, you could add in multiple settings if you want by separating them with commas. But hey, let's do that. And now my backdrop mesh, I'll make that from back geometry, back material, and then self.scene.add a backdrop. Again, because I didn't use self dot here, I'm not going to be able to change it in update. But let's see if we get kind of a yellow square added to our scene. Let me go ahead and build this one. And sure enough, we've got kind of a yellow square sitting in the background there. And so you can add all sorts of different objects as you wish. And that'll do it. Congratulations on successfully rendering a scene. In the next set of videos, we're going to start adding some other geometric shapes to our framework so we can do more than just rectangles and boxes. But congratulations, thanks for watching, and we'll see you in the next video.